for this warm-up, we're going to apply to a real-life situation the definition of what the derivative is, using one of the two formulas. Here's the statement. A particle moves along a straight line. For t greater than or equal to 0, the position of the particle is given by s equals f of t equals t squared minus 5t, where s is measured in meters and t is measured in seconds. Find the velocity of the particle at time t equal to 7. So it's kind of like the same problem we did when we introduced calculus on section 1.1. So you're just trying to find what is the velocity at t equal to 7 for this particular function here. And we are going to use one of the two definitions at a point, the rate of change at a point. So we can either use the first definition or we can use the second definition, and they both should give you the same answer, because it's finding the rate of change of the particle at time t equal to 7. Let's go ahead and use, I think let's do the first definition. So if we do the first definition, then we're going to go at a is equal to 7, because a is going to be this one here. So a is equal to 7, t equal to 7, a is equal to 7. So let's go ahead and do that. So we're going to go ahead and do f prime at 7 is going to equal to the limit as h approaches 0 of the function f of a is 7 plus h minus f of a is 7 all over h. Okay, so now what we're going to do is actually substitute in seven plus h in for a in for t in the function. So what we're going to do here is erase all this. Going back to the function, we're going to substitute this in for t. That's going to go in each t here. Let's do that. So t is 7 plus h. So this one is going to be t squared, where t is 7 plus h. And we're going to square that. Minus 5 times t is 7 plus h. And then we're going to minus f of 7. Let me just kind of leave it alone and just write down f of 7 over h. And let's not forget we have a limit. So let's go ahead and limit as h approaches 0. Okay, so this is just all pretty much algebra that we got to do next. Okay, so from there, let's go over here. So we're going to go f prime at 7 is going to equal to the limit as h approaches 0. So now you got 7 plus h squared. That's algebra here. So you got 7 plus h. Let me do this on the side here. So we have 7 plus h times 7 plus h, because you got 2 of them. And so you're going to FOIL this. That's going to be what? 49. 7h plus another 7h is 14h. And then you got h times h will be h squared. So let's put that on the top. So this is going to be 49 plus 14h plus h squared. And then we're going to go ahead and just kind of distribute this part here. So it's going to be negative 35. 7 times 5 is 35. And then we got minus 5h. And then we're going to subtract f of 7. Subtract f of 7. So then we're going to subtract and plug in 7 for every t. In parentheses, let's leave it. We're going to evaluate. So this is going to be 7 squared minus 5 times 7. And this is going to be all over h. So now we continue on with f prime at 7. And that's going to equal to the limit as h approaches 0. And it's just a bunch of algebra here. We could just do this part here. We could just work that out. 7 squared is 49. And then this is minus 35. 49 minus 35 is going to be 14. So this turns out to be 14. The whole answer inside of the parentheses. So now we can just kind of get all the constants together. You got this, and this. So we can just go. Let's put the h squared first. No, let's move the h squared first. Then I'm gonna put the plus 14h. Then I'm gonna put the minus 5h, and then I'm gonna go ahead and write down the 49, the constants, minus the 35, and then minus the 14. Over h. Okay, so the f prime at 7 will equal to the limit as h approaches 0. Okay, we continue on. 49 take away 35, that's going to be 14 here. But then we got 14 minus 14, so this whole thing goes away. For these 3 parts here, okay, we can actually subtract 5h from 14h. So we are going to have h squared plus 14 minus 5 is 9h over h. Alright? So as we continue, we can on top factor out an h. So we can go ahead and do the limit as h approaches 0. Factor out an h on top, and then you got h plus 9 over h. And we can now cancel out an h. Cancel out h and h on top and bottom. And now we can go ahead and substitute the h is equal to 0. And if you, so we got the limit as h approaches 0 of h plus 9. We can go ahead and just plug in h is 0, so it will give you 9. So to answer the question, what's the velocity of the particle at time t equal to 7? The velocity is 9, what is this? Meters, 9 meters per second would be the rate of change, or the velocity at that point. Okay, good.